We have the data of 5 participants who participated in a study. They are measured 4 times in week 1, week 2, week 3, and week 4. And now we don't want to compare 2 groups, as we often do, but we want to compare the participants with themselves over time to see to what extent they differ between the different weeks. So to test if they differ over time, we need a repeated measures ANOVA. And for this analysis, we need the mean score per week of all participants and the variance per week. We also need the mean score per person and the variance per person. These values can be calculated based on formulas discussed in a previous video, or you can request them in R with the functions mean or var. Now we will start by calculating the sum of squares within. And this is the sum of squares between the measurement moments of the same person. So the formula for this is the sum of the variance for person J times n minus 1. In this case, n is the number of observations or measurements. And let me put this aside for a moment. You can see that the variance for person J is given, so you don't need to calculate this. The variance should be multiplied by n minus 1. This is the number of measurements, so in this case 4. And now we can fill in the formula. 70.67, this is the variance of person 1, times 4 minus 1, and this is n minus 1, which is 3, plus 62 times 3, plus 58 times 3, plus 74.67 times 3, plus 56.67 times 3, which results in 212 plus 186 plus 174 plus 224 plus 170, and in the end we get 966. Therefore, the sum of squares within is 966. We will continue by calculating the sum of squares model. This indicates to what extent the variation between observations between weeks can be explained by the model, such as a possible intervention or like a therapy or a training. To calculate this, we use this formula. The sum of the number of observations in week I, Ni, times the square of the mean value of x in week I minus the grand mean. To calculate this, we first need the grand mean. We can calculate the grand mean by dividing the sum of means per week by the number of weeks. We can fill in this formula. The grand mean is 9.6 plus 15.4 plus 19.2 plus 28.6 divided by 4. This equals 72.8 divided by 4, so the grand mean is 18.2. And now we can fill in the formula for the sum of squared model. This is the number of observations in week I, which is 5 times the mean of week I, 9.6, minus the grand mean, 18.2, squared, plus 5 times 15.4 minus 18.2 squared, plus 5 times 19.2 minus 18.2 squared, plus 5 times 28.6 minus 18.2 squared. This equals 5 times 73.96 plus 5 times 7.84 plus 5 times 1 plus 5 times 108.16. This equals 369.8 plus 39.2 plus 5 plus 540.8. And therefore, the sum of squares model equals 954.8. To make space for the next calculation, I will move this to the side. Okay. The next calculation is the sum of squares residual. The sum of squares residual indicates how much variance in scores can be explained by factors other than the model. The sum of squares residual is calculated by subtracting the sum of squares model from the sum of squares within, which we both just calculated. Therefore, we will now subtract the value of the sum of squares model from the value of the sum of squares within, and that results in 966 minus 954.8, which is equal to 11.2, and therefore the sum of squares residual equals 11.2. We continue by calculating the degrees of freedom, and these are needed to be able to calculate the f value. The degrees of freedom of the model, also the df model, equal k minus 1. The degrees of freedom of the residual equal n minus 1 times k minus 1. So let's put this aside so we can fill it in. The degrees of freedom of the model equal k minus 1, in which k is the number of observations. So 4 minus 1 equals 3. The degrees of freedom of the residual equal n minus 1 times k minus 1. The number of participants, 5 minus 1 is 4. Times the number of observations, 4 minus 1 is 12, and therefore the degrees of freedom of the model equal 3 and the degrees of freedom of the residual equal 12. The next step is to calculate the mean square model, and this is the sum of squared model divided by k minus 1. So let's fill in that formula. We divide the sum of squares model, which we just calculated, 954.8, by k minus 1. This is the same as the df of the model, as you can see already. And this means that the mean squares model is equal to 318.72. And we want to make some space for the last calculations now, because now we still have to calculate the mean square residual. And that is the sum of squares residual divided by n minus 1 times k minus 1, equaling the degrees of freedom of the residual. We just calculated the sum of squares residual, and n minus 1 times k minus 1 equals the degrees of freedom of the residual. I'll put this next to the other formulas so that we can fill it in. The mean square residual is the sum of squares residual 11.2 divided by the degrees of freedom residual 5 minus 1 times 4 minus 1, which is equal to 0.933. And therefore the mean square residual equals 0.933. We're almost done because now we can calculate the f value. The formula for calculating f is the MSM divided by the MSR. We already calculated these values, so let's fill in the formula. Our board is getting a little full, but we're almost done. We can enter 318.27 divided by 0.933, which equals 341, and thus the f value equals 341. And you can look up the corresponding p-value in a table, or you can request it in R by using the function visualize.